Since NASA's Juno probe reached Jupiter in July 2016, scientists' views of the solar system have undergone a significant change. What was discovered by Jupiter on the Juno spacecraft? What other spacecraft brought us a surprise from the gas cloud? And why have scientists been so baffled by the most recent discovery? Let's find out, shall we? Amazing images of the gas giant hundreds of millions of miles from Earth were captured by the $1 billion project. Jupiter's size and prominence in our solar system has earned it the nickname King of the Planets. The term kinghood has been used in several societies in history, but this is the largest instance. It stands out against the night sky and is brilliant. Incredible images from spacecraft demonstrate that Jupiter has been explored for hundreds of years and is still being explored today. Jupiter travels around the Sun in a full circle once every 12 years on Earth. Jupiter's 483 million miles, or 778.5 kilometers, proximity to the Sun causes it to have a long year. A planet passes in front of each cluster for about a year, which long-term observers will notice because the further away a planet is, the longer it takes to complete an orbit. Jupiter has a very long year because it only has a few hours of sunlight per day, and one revolution around its axis takes about 9 hours and 55 minutes. Unlike the atmosphere of Earth, Jupiter's atmosphere reaches the planet's core and touches every continent and ocean. Despite this, it is not completely gas. At some point, hydrogen turns into a liquid due to increased pressure and temperature as it draws nearer to the core. It turns into a metallic liquid that surrounds a small amount of rocky interior. Planetary scientists estimate that at least 70 moons are orbiting Jupiter, including Io, Europa, Ganymede, and Callisto, and that there are more than 60 other small bodies orbiting the planet. The 4 largest moons of the planet are in close orbit, the rest are smaller, and many of them might be captured asteroids. When we first studied the solar system as children, we were taught that each planet has a unique orbit around the Sun. Unless you're one of the many who are shocked and sometimes get upset to learn that Pluto is not actually a planet, you might want to get ready for another unexpected cosmic discovery. The Sun and other planets actually orbit a common gravitational core because it is so much larger than Earth. Jupiter doesn't revolve around the Sun, but it still has an orbit. Neither of the planets orbit the Sun in a perfectly round path. We appear to be circling the Sun because our center of gravity is so close to its center. Except for Jupiter, the gas giant, that's also truly the case for every other planet. What exactly is Jupiter doing if it isn't revolving around the Sun like the other planets in the solar system? It is clear, and the Sun and Jupiter are orbiting the same location in space because Jupiter's size causes the Sun's center of gravity to be pulled away from its surface by a distance of about 30,000 miles. The technical name of that place is the barycenter. In contrast to the other smaller planets, Jupiter is the only planetary body big enough to show the effect, despite the fact that all planetary bodies have such an unstable relationship with the Sun. Jupiter even has its own ring system, despite what many people think. You'll probably get some big planets, some small planets, and Jupiter if you ask everyone to draw the planets. Jupiter does not orbit the Sun in addition to this merged center of gravity because the point is forcibly removed from the Sun's center. Jupiter's gravitational pull causes the Sun to move slightly. Although less obvious than Saturn's rings, Jupiter, Neptune, and Uranus all have rings. The discovery of a thin dusting encircling Jupiter was one of the most significant discoveries made during the period of Jupiter exploration. Although it was photographed by Voyager 1 in 1979, the Jupiter ring is not really a visible ring set. The majority of the dust in the system, according to planetary experts, originates from a few minor moons. Jupiter has long held the attention of astronomers. After developing his telescope, Galileo used it to study the globe. He was shocked by what he noticed nearby. He noticed 4-minute movements that allowed astronomers to look through telescopes at cloud zones and belts. Spacecraft had sped by in the 20th and 21st centuries collecting data and images that were getting better and better. The first spacecraft to conduct up-close examinations were Pioneer and Voyager, and the final spacecraft in this series, Galileo, orbited the planet and conducted extensive observations. The New Horizons spacecraft and the Cassini probe to Saturn also passed by and collected data. The far more recent mission specifically intended for studying the planet was the amazing Juno mission, which captured photographs of the beautiful clouds in incredibly high resolution. Prior to the arrival of Juno in 2016, neither the top nor the bottom of Jupiter's poles had ever been captured on camera. Scientists received data from the probe after it crossed Jupiter's poles for the very first time. Observatories like NASA's Hubble Space Telescope have found auroras at Jupiter's poles, but no one had ever seen the mysterious region in the detail that Juno has revealed. There are many storms up there, and the sky is bluer than anywhere else on Earth. That is something we've never seen or even imagined. There are no latitudinal bands, zones, or belts to be found. In fact, it's difficult to tell if Jupiter itself is in the picture. Furthermore, the weather on the planet is a lot more complicated than previously thought. Scientists were able to uncover hundreds of kilometers of hydrogen, helium, and other chemicals by peeling back Jupiter's atmospheric layer upon layer like an onion, thanks to Juno's initial close approach. Deep underground, one can still see the zones and belt-like structures. Therefore, everything in charge of those hues and streaks is still very much alive and well inside Jupiter. Many scientists were surprised by this. However, further research indicates that belts and bands may begin more than 1,900 miles beneath the planet's gaseous surface. Additionally, NASA offered breathtaking images of symmetrical storm clusters. The images were created using a series of infrared photos, a wavelength that is normally invisible to us. Scientists then combined the images to create 3D models that highlighted temperatures and brightness. Jupiter's Great Red Spot further suggests that perhaps the planet is water-rich. Numerous Jupiter moons contain water and may even have vast oceans where alien life forms may exist. Jupiter, however, has seemed to be dry on the surface, and it hasn't proven easy to locate signs of water molecules on the planet. Juno is addressing this problem with a variety of sensitive instruments and ultra-close flybys. The combination of data from Juno and data from the Great Red Spot that were gathered by telescopes allowed researchers to get a more thorough look at Jupiter's atmosphere. According to their findings, the planets may contain up to 9 times as much oxygen as the Sun, and everyone is aware of how vital oxygen is to water. Jupiter may also have a much larger, fuzzier core than previously believed. The term fuzzy refers to the state of hydrogen in Jupiter's interior, which is partially dissolved and partially gaseous. Earth, in contrast, has a solid core and an outer liquid layer that rotates around it. Jupiter's fuzzy core, which is similar to the metallic powerhouse in the Earth's core, may be what powers the planet's magnetic fields and dynamo. Previously, it was believed that hydrogen, which is normally a gas and has been condensed into a molten material state, was responsible for Jupiter's magnetic fields. There are other aspects of the planet that are unclear to experts as well. An unknown force is mysteriously propelling Jupiter's auroras. The source of auroras is a planet's magnetic field. This field gathers charged solar particles that are launched into space and propels them in a race towards the poles of the planet. When the particles strike gas atoms in the atmosphere, an amazing light display is produced. The polar auroras on Jupiter, however, had 10 to 30 times more energy than expected, and most of this energy is released as ultraviolet light, which is invisible to humans. This discovery was made by Juno scientists. As the world spins into darkness, the auras also diminish. Scientists believe that Jupiter's mysterious plasma field may be connected to the planet's auroras, despite the fact that their exact causes are still unknown. As it travelled further, Juno discovered evidence of a possible new volcano that formed on Jupiter's moon Io. On the moon, what does seem to be a previously unidentified volcano has been found by Juno's infrared camera. According to estimates, there are 150 active volcanoes in the world. Nevertheless, the volume of debris erupting from the surface of the planet and travelling into space raises the possibility that there are still another 250 hiding in the shadows. It serves as a potent reminder of how little we know and what more there is to learn about the world. Let us know your opinions in the comments section below.